All right, so good morning. So today what we will do is do this numerical on the topic of angular momentum. Angular momentum is a very important topic for your examination, and it helps you immensely in both class 11th and 12th. All right, so let's see the problem. Uh, this is a system where the origin has been fixed here. So this is your origin. Okay. And remember, in angular momentum, the choice of origin will decide the angular momentum. So please be careful when you are doing angular momentum for a single body. So you can do angular momentum for a rigid body, and you can also do an angular momentum for a single body. Okay, so this is your rigid body. What we're concentrating on today is the single body. Now, the choice of origin is very important. It is not an inherent property of the body. Body does not possess angular momentum. It is with respect to origin. Okay? So if you choose origin somewhere else, the angular momentum will change. That is what it means. So choice of origin will decide the amount of angular momentum you have. It's not an intrinsic inherent property of the body. Okay. Now let two more words on angular momentum. Okay, it's a vector product. So what you see is three masses, 1, 3 kgs, 2 kgs. This has a velocity of 1 meter per second, 3 meter per second. And I think the last body has a velocity of 2 meter per second. So I hope you're reading the question also. 2 meter per second. Now, angular momentum, let's discuss it, is represented by N and is given by M R cross V. Okay. So it's a vector product of position vector and the velocity, which means if I draw a system like this, okay, if I draw a system like this, okay, and this is your x-axis, and this is your y-axis, and this is your z-axis. And if this body, which is moving, is in x-z axis with a velocity v, okay, and then, so let's say the momentum of this body, the linear momentum of this body is directed like this, okay. The position vector is here, and there is an angle between them. I've shown it very simplistically. So let's say that momentum of the body in the xz plane, in the plane itself, is this, right? So xz, and this is the momentum. This is your r vector. This is the position of the body with respect to the chosen origin. So that's your origin. The body is placed here, and it is moving with a linear momentum of p. Okay. Now what I do is I extend the line r. Okay. So what we need to do is r is extended, so it looks like this. So in the xz plane, which is here, okay, you have a body having a linear momentum and a r. The angle between them is theta. Okay. What you do is A cross B. So you apply the screw rule, and what you get is M R V sine theta. And if I move it like this from R to P in the XZ plane, R cross P, the angular momentum is directed upwards in this direction. So MVR, if I have to write the direction, I will put a J here. Okay. So R cross V is very important for you to understand. Okay. It is A cross B situation. It's a vector product. Okay. So whenever you're solving a problem of angular momentum, you just don't need to look at whether it's a case of single body or rigid body, but also add another dimension in your mind, which is to do with the fact that it's a directional thing. It's a vector product. Okay, so the answer, angular momentum, comes out to be a vector, and this will use this. Okay, now let's come back to our problem. very importantly, sorry, I'm just repeating, the angle between A and B, okay, A and B is theta. This angle is also very important because if this theta is 0, you get angular momentum to be 0. And what is the meaning of the word 0? We will see it shortly. So let's analyze this question now. I'm going to highlight the masses. So this is your mass, this is your mass, and this is your mass. Okay, so you have situation like this. I now talk about the 3 kg one. If you notice, 3 kg has an a linear momentum in that and the in this direction. So what is the linear momentum of this, right? This is 3 into 3 is equal to 9 kilograms meter per second. So this is your linear momentum, and the position vector r is in the same direction, right? So you can see r is this, r, and p is also in the same direction. So if I have to write L for this 3 kilogram body, how do I write this? I will just use this is equal to 3 r is okay. I don't know exact value, but it's some theta maybe given to you, and you can break it down into a position vector. But more importantly, you can see it will be sine of what? I've just written as r into v, right? So this is the mass, the position vector, the velocity 3, angle is 0. Because the linear momentum and the position vector are in the same direction. So the angle between them is 0, and therefore the angular momentum of 3 kg mass is 0. Right? Let's talk about the angular momentum of this particular body. Okay. So this body is moving in this direction. Okay. And its position with respect to the chosen origin is this. So your position vector is this. Your linear momentum is here. Okay. Now we know the angle between the R and P is 90 degree. Okay. Angle is of tremendous significance. And then we will see the directional sense also. And we have to do R cross V, right? R cross V goes inside, right? So the angular momentum is directed inside, and therefore the angular momentum is 1 into sine 90, and it is going inside, right? So I'm just going to write the word inside, okay? So this becomes 1 kilogram meter square per second, right? That's a units. Meters and meter per second gets combined, right? Then, so anyway, so I hope this is clear. So angular momentum is inward. Let's talk about this particular body. The linear momentum, the velocity vector is in this direction, which is upwards. The r is in this direction. So if I extend this r, this is my velocity vector, and I do r cross v, the vector is coming out, right, like this, towards u. Okay, so I hope you know a cross b and is equal to minus b cross a. So this is your r, and let's do this now. The angular momentum of this body is equal to 2 into 2. Okay, so 2 into 2 into, okay, let's look into the angle also. The angle is again 90 degrees, right? So 2 into 2 into sine 90. And I'm going to write it as outward, okay? So n v, and what is this distance equal to? Let's see this distance. This is 2 meters, right? So this is 2 meters. So 2 into 2 into, so mass r into 2, right? So velocity is also 2. So this becomes 8 kilogram meter square per second outward. We know the individual angular momentums. What we do is now the vector sum. Okay, because of the question, this solution got hidden in this part of the last leg of the solution. So I'm just putting it across. 8 is outward and 1 is inward. The net angular momentum is 7 kilogram meter per second square. I hope this helps you understand the concept of angular momentum. And therefore, the net answer is 7. So you can see the choice number 4 is the correct answer. I will write it as 7 kilograms meter square per second. Very important question if you're preparing for AP Physics, you're preparing for IB Board, you're preparing for GCSC, or you're doing any NEET or JEE mains in India. This type of question where they test you for your understanding of vector, directional sense, your understanding of being able to do a vector product, stuff like that, is very, very useful. Again, for the sake of, at the cost of being sounding repetitive, angular momentum is primarily driven by the choice of origin. Okay, so since the origin was this is the way we got it. It's not a property of a single body inherently that it has an angular momentum. It purely depends on where your origin is. This can be another question to you. Okay? So I hope you understood the angular momentum of a single body, the vector format. How do you sum it up when you're given multiple bodies and find the answer? Thank you very much. Don't forget to subscribe to this channel. You will see some wonderful conceptual practice questions with detailed explanation coming your way. Thank you very much and look forward to see you soon.